All right, let's dive into something pretty wild today. It's an open source AI project called Project Aura, and it's exploring a feature that sounds, well, incredibly human. The whole thing is built around this one simple but kind of revolutionary idea.
Yeah, what if an AI could sleep to learn better? I mean, we usually think of AIs as these tireless machines, right? Just crunching data 24/7. But what if they're more like us? What if they need to rest, not just to, recharge, but to actually get smarter?
So, let's get right to the source. The project's own GitHub page says it all. It features, and I'm quoting here, the first empirical implementation of neural sleep cycles for memory consolidation. Now, empirical implementation is just a fancy way of saying they actually built this. This isn't just a white paper idea. And that key phrase, memory consolidation, that's literally what our brains are doing every single night when we sleep.
Okay, so before we can really get why this AI needs to sleep, we got to understand what makes its brain so different. We're not talking about your standard AI here. Project Aura is built on a totally different bio-inspired foundation. And here's where it gets really cool. Think about a traditional AI. It runs on what are called static weights, basically a giant collection of fixed numbers. You can think of it like a photograph, right? It's a static snapshot. But Aura's AI, it uses dynamic phase oscillators. Its neurons are more like rhythmic wave-like pulses. So it's not a photograph. It's more like a constantly evolving piece of music. It's alive, it's dynamic.
So the natural question is, what happens when this musical brain tries to learn for too long? Well, you can probably guess. Just like a guitarist whose fingers get sore after hours of practice, this AI starts to face a very unique kind of problem.
The technical term they use for this is homeostatic drift. And what that really means is it's a buildup of instability. The network gets fatigued, those nice rhythmic oscillators start getting out of sync with each other, and the whole system just gets wobbly and less efficient.
Let's just call it what it is. It's AI burnout. Simple as that. It's the exact same feeling we get after cramming for an exam all night. The system is just overwhelmed, and its ability to learn starts to tank.
Okay, so if the AI gets tired, if it starts to burn out, what happens next? What does the system actually do about it? How does it fix itself?
Well, lucky for us, we don't have to guess. We can look at the actual evidence. We're going to dive right into the training logs and watch one of these sleep cycles happen in real time. Let's see if this whole thing really works. Okay, check this out. We're looking at the logs right at step 59640. And you can see it right there. Reason for sleep, drift. And look at that homeostatic drift value. It's at 1.0056. It's crossed the line. That's the signal, that's the AI basically saying, I'm burnt out, I need a break.
And then this happens. Neural sleep triggered. And I love the wording here. It's applying a gentle homeostatic reset. It's not just yanking the plug and rebooting. It's doing something careful, something designed to ease that fatigue without wiping out all the hard work it's just done. And here's the after picture. Wow, just look at that. The homeostatic drift got sliced almost perfectly in half, down to about 0.5. But that's not even the most amazing part. Look at the bottom. The result is okay consolidation, and there's a learning improvement. The AI didn't just get rested, it actually got smarter. And that right there is the key. This is the whole point. Sleep isn't just about hitting a reset button on fatigue. It's an active, essential part of how this AI learns. It's literally helping it organize its thoughts and get better at what it does.
Now, you might be thinking, okay, but was that just a lucky break? Nope, not at all. Across the entire experiment, the memory consolidation was successful 73.3% of the time. That's a huge success rate. It shows this is a consistent and reliable process. And this chart really just spells it out for us visually. On the left, you've got the average drift before sleep. On the right, the average drift after sleep. I mean, it couldn't be clearer. Across all the sleep cycles, that burnout metric was consistently chopped in half. It gets tired, it sleeps, it wakes up better. It's a perfect cycle.
All right, so we've seen the nuts and bolts, we've looked at the data. But so what? Why does a sleeping AI actually matter? Let's zoom out a bit and think about the bigger picture here.
What this really means is that we're looking at a brand new way to keep these incredibly complex AI systems stable. By making them a little more like us, a little more biological, we might be on a path to AIs that are way more efficient and just tougher. It really proves that building better AI isn't just about more power and more data. It's also about giving them time to rest and recover.
And that just leaves us with one last, kind of mind-bending thought to chew on. As we keep building these artificial brains that are getting more and more complex, are we realizing that the next big breakthrough isn't just teaching them to think faster, but teaching them to do something we all need, to rest?